Alright, so we are going to do this just a little bit like a flipped classroom. I do this occasionally just to keep you guys on your toes. But for the second type of bonding, we are going to talk about metallic bonding, which is bonding between metals. We spent the last couple of days talking about ions and ionic bonding. There's three main types of bonding. Now we're going to move on to type number 2. Alright, so for metallic bonding, we have to think about all of the metals and we have to think about properties of metals. So in metals, valence electrons are mobile and freely float from one part of the metal to another. This is why they are good conductors. This is why they give and they release heat really quickly. This is why they absorb heat really quickly. This is why they are good conductors of electricity. This is why they have all of those good metal properties that you guys know and love and think of instantly when you think of metals. Okay, the attraction of these free floating electrons is what holds metals together. So basically, everybody wants electrons. Everybody wants to have a certain amount of electrons. And since electrons can flow freely from one metal to the next, it is the electrons moving from one atom of one metal to another atom of another metal that allows metallic bonding to actually take place. We're actually going to do a lab with this on Monday, which is why I'm giving this to you for homework on Friday. So let's talk about properties of metals. So first of all, a couple of properties of metals are they're conductors of electricity. They are also ductile, which means they can be drawn into wires. They are malleable, which means you can bend them and force them into specific shapes. They are also crystalline, which we talked about a little bit the other day with ionic compounds. But basically what that means is they are very compact and orderly, so they have a specific shape. This leads us to something called an alloy. Now some people say alloy and some say alloy. It really doesn't matter whichever way you say it. But basically this type of metal is actually a mixture, which if you think back to a few units ago, we compare the difference between elements, compounds, and mixtures. Mixtures are a combination of two or more elements that are physically combined. So we're not changing the chemical compound together, we're just simply stirring them together. So in order for you to have an alloy, you have to have at least one metal. So one example of an alloy that you guys have all seen before is brass. Brass is an alloy of copper and zinc, which are both metals. You take copper and you take zinc, you melt them down, you mix them together, and then they solidify, and ta-da, you have brass. So usually, properties of alloys are stronger than their counterpoints. That's why they are used so prevalent. That is why they are such a good thing. So like, for instance, silver is honestly not a great choice for jewelry because silver tarnishes really easily and nobody wants to wear jewelry that is black. So somebody created something called sterling silver, which honestly you just take silver, Ag, and copper, you melt them down, you mix them together, and you get a much stronger silver looking jewelry that doesn't tarnish and is actually a lot more stronger, and so it doesn't bend as easily, and so therefore it's a little bit more sturdy. So you kind of get the best of both worlds. You take the strengths of silver, you take the strengths of copper, and you get a better metal. Another example is bronze. Bronze is actually the mixture of copper and tin. Tin is actually a pretty weak metal. Copper is a pretty strong metal. When you mix them together, you kind of get the benefits of both of them, and you get bronze. And then the last one is steel. Steel is actually a mixture of lots of elements. This is actually what I was for Halloween that day we dressed up. Steel is a combination of 10 or so different elements all mixed together. Alright, so there are actually two types of alloys. The first one is called substitutional. These are components of the alloy are about the same size, so they just honestly replace each other in the crystal. So like for instance, if we are taking copper and zinc are approximately the same size, they have really close to the same mass, they have the same number of protons, so on and so forth, so they just honestly replace each other, and so the structure doesn't really change. However, in interstitial, these atomic sizes of the components are very different. So these are actually a little bit stronger because what happens is the smaller atoms will fit into the spaces between the larger atoms, actually making the metal stronger. So these are actually the better form. Substitutional is still good, but interstitial is actually a little bit stronger because there is less empty space in the mixture. Alright, so here is your homework. It's actually only 5 problems, so it kind of just reviews it. Please just add this on to the other homework that we've done so far in this unit. This is the 3rd assignment. And hopefully if you do this, you'll be ready to do the lab when we come back to class on Monday.